All right, thanks everyone for coming. Recognize many of you from last year and years before, and it's good to be back again. Thanks to our hosts, echoing what Michael Dexter said earlier. Start with what I normally do. This slide deck looks like a lot like the previous ones. Start where we were a year ago, and actually I'll even go back a little bit further and talk about where we were 2 years ago when we first started coming to VHiveCon to talk about VMM. Where we're at, what we did last year, kind of what our future plans are, and then wrap up with Q&A. So this will be kind of a mixed bag of technical topics, what we've done, what we've improved, and where we're still looking for help and improving things. So before I go over 1 year ago, let's talk about 2 years ago. Anyone was here 2 years ago when we were in the other building? Oh yeah. So 2 years ago was the very first kind of public demonstration of running a virtual machine in OpenBSD from the built-in OpenBSD hypervisor. And if you remember, if you were there in the other building, I got up and Michael Dexter said, let's see a demo, and I went, all right, let's try it. And fortunately it worked. It was pretty limited at the time. It was OpenBSD guest, AMD64 guest, AMD64 host only. And the way that we handled clocks was like this kind of very crude way of saying every so many exits we would just insert a hard clock interrupt, so the time was all screwed up, and it was kind of really a big mess. Fast forward to 1 year ago, and things became a lot better, primarily because we actually were able to get some of the community to help out doing some of the development and some of the fixes. But last year, when we were here talking about this, we had decent support for OpenBSD guests inside OpenBSD VMM, and not really much else. And if you were here last year, you remember kind of the challenge was to get more guest operating systems working, specifically Linux. Back then we had AMD64 936 host support, very basic and early SVM support, and you don't know what SVM is, that is the AMD hardware virtualization extensions. So we had very basic SVM support. What that really means is like it worked on one machine or one kind of CPU. And we had some tooling and some command line utilities and daemons for controlling VMs, and it was a little bit unstable at times. It would crash. The best example of this was something I ended up fixing after VHiveCon in the lobby of the other conference. After 26 days, every 26 days, all your VMs would die. You figure out why? The counter wrapped. It went to 0 and then divide by 0. So yeah, it was just crazy stuff like that. So that's where we were a year ago. And up until that point in time, it was primarily myself and Reich working on this. There were a few other people that were helping out from time to time. It was really kind of a two-person show. And over the last year, we've been able to solicit a lot more input and a lot more help from the developer community at large, so that's good. So this past year, we've been kind of improving and solidifying the core features, making things a lot more solid, a lot more robust, and of course, adding new guest OS support. Again, primarily that's Linux, but as I'll discuss in a few minutes, building all the pieces necessary to support Linux guests also gives us other guest OS support that we really didn't anticipate. And like every year, bug fixing, paying down technical debt, although I think the number of bugs that I'm keeping track of locally has gone up since last year, so it's always the case. So in 2017, kind of the high-level goal that I had, at least for myself, was to improve our guest OS compatibility. And thinking back a couple of slides, last year we really only had support for OpenBSD guests, and the primary reason for that was we only loaded the kernel through an ELF loader that was built into our VM control daemon. So we didn't have any way of actually starting the machine from BIOS and booting up what a real operating system would be expecting. So kind of the first and foremost thing we had to do last year was build in support for some kind of BIOS or EFI. So what did we do? We started loading a cBIOS binary and started executing inside a VM and see where it stopped, see where it crashed. And then went and fixed that problem, and then fixed the next problem, and then fixed the next problem. And this took a lot longer than I thought it would. We eventually got there. I was missing a bunch of interrupt controller and clock features that were used by cBIOS to do various early bring-up sorts of technical things that it needs to do. Missing a bunch of PSAC and fixed space features, specifically remapping bars. That was missing. That was not in VMD before. And missing some real-time clock features. And this is not so much that we were missing the clock part of the implementation, but we were missing some NVRAM control variables that were written into, they were expected to be present at certain offsets in the NVRAM, such as the size of memory, number of CPUs, and so on. There was probably more on this list that I'm forgetting about, but that was what we did. We started and just nibbled away at it until we actually had everything working. We also can run with UEFI. We don't ship that today, but the UEFI payload that I think the Beehive uses, someone said it worked. I don't usually use that one though. Once we got that all wrapped up, we now package CBIOS for delivery to OpenBSD hosts via firmware update. So basically what we do is we treat BIOS as the firmware for the hypervisor. So if you've used fw_update to update your wireless card firmware or your graphics card firmware, you just run fw update. We detect that you have VMX or SVM capabilities, and we pull down a CBIOS compiled package from one of our ports maintainers. So that's easy. We don't deliver it stock. We don't deliver it as part of base. It's wrong license. And also there's some people who just say, well, we don't want to have anything of the wrong kind of license in base. So you don't have to use this. If you don't use the CBIOS package that we ship as part of the VMM firmware, you can still use VMM and VMD, but you're limited to OpenBSD guests. We still have the old ELF loader for loading OpenBSD kernels directly, and that does not need this to work. So it is CBIOS, it is running in real mode. So it does need a CPU that's capable of the unrestricted guest VMX capability. So what that means for most people is that you need a Westmere or later CPU. That is about a 2009 or 10, I think, era CPU. So most CPUs have this already. Where this becomes a problem is in older machines or machines where you're running in a nested environment that don't necessarily expose all of the features to the upper layer guests. So that's a sad face. It's always a sad face every time I see that, because it's always been a side tree that I've had to remove the need for all this. We do have a 16-bit real mode emulator in our tree. It actually has nothing to do with VMM. It's used in two places. It's used in X, and it's also used in our suspend resume framework for reposting VGA cards on resume. So in theory, we could go grab that and have that run CBIOS for these older machines, but we don't do that today. In addition to building up support for BIOS, which gave us indirectly support for other guests, we improved a lot of other areas in the platform, substantially rewrote the SVM code at one of the hackathons last year. So now our AMD support is pretty good. There's still, I think, one model of CPU where it gives us a little bit of trouble, but by and large, it's way better than it was a year ago. AVX, AVX2, AVX 512 guest support. We weren't really handling that properly before, and now we are. We were actually leaking floating point context earlier when we first implemented this. So AVX support was actually the first security errata that we put out for VMM. So we now support all these different AVX guest modes. We also have a TSC timestamp counter support in the guest as well, which helps avoid too fast or too slow time in the VM. That's not exactly perfect yet, but it's getting there. If you have a compatible host, we will pass through the timestamp counter capability, and that helps the VMs keep accurate time now. I have a couple of long-running VMs at home that have been up for 40 or 50 days, I think, and they've drifted by like a second, so it's pretty good now. This is just an example. I counted CVS commits last night for VMM, VM control, VMD, and there was like 350 commits, so this is not all a big list. There's a lot of small bug fixes that went in there as well. Okay. So let's talk about guest OS support. This was the bigger challenge that I had last year, was to support more guest OSs, specifically Linux. So that's where we started with the BIOS support. And now we have Linux guest support, 32, 64-bit. As far as I know, there's no non-functional distributions, but of course there's as many Linux distributions as there are Linux users. So if there's one that doesn't work, we can make it work. It's interesting, the last one to be added was one of the more common families, was CentOS and Red Hat, and that was because their installer required CD-ROM support. And, or at least that's the mode we were operating in. You'd get halfway through the installer, and it would say, I'm going to go look for packages, and it would do essentially like a dmessage and grep for SR or whatever the Linux device is, and it wouldn't find anything, because we presented everything as versatile block devices before, and that would just cause the installer to crash. So you had to either do a network install or something else, and it was a big mess. So we had a new face appear on our mailing list that I'd like to bite off CD-ROM support. And I said, here you go, have a good time. Talk about that in a second. We got that done, and now, of course, that installs properly. We're still VirtIO based, so all of our devices, the guesties are still VirtIO devices. You can redirect X locally via VNC. This is not good for watching cat videos or anything like that on YouTube or Netflix. This is good for running Xterms or other kind of graphical tools and things. But you can redirect everything locally through the network interface that the guest provides. Because we did this, we actually got other guest OS support kind of for free, which came as somewhat of a surprise. Some of these uncommon ones just suddenly started working once we implemented a bunch of these other features. So DOS works, woohoo. Plan 9 works, woohoo. I booted that and I had no idea what to do. I just was typing commands and couldn't figure out how to use it, but it did boot. Android works, which is another interesting one. There's no graphics on it. It really is just Linux, so it's kind of really nothing different than the previous slide. We also had another guy appear on our mailing list, Adam Steen, who appeared and said, I need some help making the Solo 5 UKVM microkernel engine run on VMM. So he bit off that effort and got that working, so appreciate that help. Now that I have some Solaris and Illumos, SmartOS guys in the room, I can ask them maybe about this later. This one is still a head scratcher. I got some PMAP issues with the Solaris kernel, and I'm not quite sure what's going on there, but it does boot much further than it did before. So what does that leave? We got Linux, OpenBSD, we got a bunch of weird OSs. Yeah. What about FreeBSD and NetBSD? We have a new developer, Pratik. He used to be a student of mine at San Jose State, actually. He got these locally working. The issues that we have with FreeBSD and NetBSD have to do, well, first with FreeBSD. FreeBSD uses bus space write multi, which is a function for doing I/O. Uses that in the console. So what ends up happening is you can see all the autoconf messages come, and then as soon as interrupts are enabled, it switches modes. And it ends up turning into an instruction to do fast console I/O. There's a rep out SB from memory. So it's like rep out SB star RDI or something. And this may not sound like a big deal, but this requires an instruction decoder and an instruction emulator. And surprisingly, we've been in VMM development now for like over 2 years, and we haven't needed one yet. And I've been intentionally pushing that off as long as possible. That is one of the most complicated areas of the hypervisor to write. It's also one of the areas where if you make a mistake, that could be catastrophic from a security perspective. So what does that mean? Well, what do you need to do here? Well, this would be something like a string in memory that's being printed to the serial port, and it's located somewhere in guest virtual memory. So the first thing you have to do when you trap this I/O in your hypervisor is determine where that is in guest physical memory, and then walk through the page table a second time, the nested page table, to find out where it is in host physical memory, and then reverse that back up to some place that you have access to. And if you fail to do everything the processor does during that check, for example, checking segment limits, checking permissions, checking modes, and all these kinds of things, then you end up potentially opening up a massive security hole. And it's not that this is impossible to do or that it hasn't been done before. There's actually lots and lots of places to look for sample code. Just I want to make sure we do this exactly right, and I want to take our time doing it. So he got that working in a basic mode of operation. We're still getting that nailed down. But with this, you can boot up NetBSD and interact with it, install it. And FreeBSD is actually has a different issue. It's not really a FreeBSD issue, it's more a VMM issue. The AMD64 FreeBSD kernel assumes that it's on a relatively recent machine, and as you'll see later, we don't emulate kind of a really current machine in VMM and VMD. We emulate a machine from quite a long time ago. So if you try to install by default the FreeBSD ISO image, you get through the bootloader and you get through the first stages of boot, and then it complains that it doesn't have the right kind of interrupt controller. Well, it's kind of not FreeBSD's fault, because they're expecting to have an interrupt controller that matches the CPU that's being shown. So there's some still disconnect there. If you rebuild the kernel, you can get a little bit further, but we still run into similar issues like this. So it's ongoing. We have someone looking at it, and we'll get there. That was the VMM, so that was like kind of the kernel side improvements. There's also some improvements that went into VMD, which is our user space component of the VMM's implementation. Like I said, we have Carlos Cardenas, who appeared on our mailing list and said, I'd like to tackle doing CD-ROM and DVD-ROM device emulation. So I said, great, here's the VirtIO spec, have at it. And then we quickly found out that we need the SCSI spec too, and this other spec. And this was quite a bit more work than we thought it would be. So we now have VirtIO SCSI host side support. Right now we only attach CD to it, but we could in theory attach disks to it as well. So that was done, and again, that gave us the ability to do installs for some of the Linux distributions that are out there. We also have something that Ray did earlier last year, and we called it VMD Local Networks. One of the things that even though we're still kind of early in our development cycle here, it's only been going a couple of years, we always get asked, how can you make it easier? So people would come to us and they'd say, how do I get networking working in my VM? And if you didn't know how to do it, you'd have to set up tap interfaces and bridges and this and that and NAT rules and PF rules. Well, what we did, and a DHCP server and everything, so what we did is we simplified it. We said, if you want to do NAT, which is kind of what most people want to do in their VM on their laptop, all you do is add one line to PF, set one sysctl, and then do mctl start -l. -l does a couple of things for you. So built into VMD is now a mini DHCP and Bootp server. So when you're running in local network mode, VMD will automatically assign the guest an address from this range. And why that range? It's apparently some kind of reserved range. I'm not a network guy, but apparently it's carrier grade NAT, and it's a reserved range, and you can change that if you want. And what we do automatically is we'll create a corresponding gateway tap interface on the host. And make a long story short, everything just gets configured automatically. So if you want to do NAT without having to set up a bunch of NAT infrastructure and DHCP servers and everything, you can just do vmctl -l. And that'll vmctl start -l. It'll set everything up for you automatically. I mentioned PD Pratik earlier. As part of his master's program at San Jose State, where I teach, he and a group of 3 other students implemented VM send and receive, or more precisely, migration. So with the new version of vmctl and VMD, you can pause and unpause, which is basically to stop and unstop a VM, and you can also send and receive VMs. So what this lets you do is it takes a memory snapshot and device snapshot of the running machine, not the disks, but it takes a snapshot and sends it to a file of your choice. Now this is just a stream, so you can really send this anywhere. You can use it like this to create a snapshot of the machine, or an in-memory snapshot. You can receive it and create it again. Or you can do something like this, which is actually something I talked about a couple of years ago when we first started figuring out what we could do. You can send a VM, pipe it into SSH on another machine, receive. And what it does is as long as the location of the disk is consistent, so as long as you have shared storage, it'll send the machine and migrate it from one host to another. And as part of the implementation, that group of students, when they were giving their demonstration, just ping-ponged a machine back and forth between 2 hosts over and over again. And of course, you can save them as backups if you wanted to create a way of snapshotting a VM there. So the way that it works is kind of interesting. It's not really different than what other hypervisors and virtualization products do. It spins and waits until the machine the VM is halted. So as soon as the VM enters, typically its idle loop, is where we will detect that a machine is to be sent. So what this really means is you can't migrate a machine that's sitting at the BIOS, because the BIOS typically doesn't do this. So it usually sits in an infinite loop instead. What the send and receive engine does is then pauses the VM. So they actually implemented pause and unpause first. And then we serialize the device and the CPU state to the output stream that you're sending it to. So CPU ID feature flags, what capabilities the CPU you're running on have, and internal legacy device state, counter state, interrupt controller state, PCI device state, everything we need to send. We then send the memory pages that are in use to the output stream, and we tear down the machine on the host. Now on resume, which can either be much later or at the same time on a different host, if that's what you're doing with migrate, We read the CPU flags and we compare to see if the host you're reading the machine into is compatible. And there's a mask of CPU features that we use to determine if that's correct. If not, we just abort, and the VM is not resumed. Then we restore the memory pages and then resume the VM. So again, it's not unlike what other virtualization products do. If you migrate a VM from one machine to another, then ideally you could be able to use switch or switchd. And again, I'm not a network person, but this is what I've been told, to manage connection state. So if you have some kind of dynamic switch or software-controlled switch, you could send a machine with active connections from one host to another. So again, if you have questions here, I'll have to answer them later because I'm not a network person. So if the demo gods are with us, we can take a look at what that actually looks like. So I've got a bunch of VMs defined on this machine. The one that's called AMD64, which is the second one, is just an OpenBSD guest. That's the one I'll use. It can be any of these. So let's go ahead and start that. And -C to attach to the console. And we'll wait for this one to boot up. All right, so this is just a VM, and I'm going to disconnect from the console now. We're going to do vmctl, go somewhere with some space. vmctl send AMD64, and we'll send it to AMD64.vm. 1, 2, 3.
Is that pause the VM was?
Yeah. About 5 seconds. It's paused migration. That's a good point. We originally started off with a lofty goal of doing live migration, and maybe we'll do that at some point. We actually have the scaffolding in there to do that now, but it's paused. So if I then take a look now and say vmctl status, see AMD64 is stopped, and you can resume it. If I spell it right. Give it a name, and you can give it the same name or a different name. Just give it a different name now, just to show that that works. AMD64.vm. And we'll read it back in. It takes about the same amount of time to read it back in. This is not a particularly fast laptop, and these aren't actually really big VMs, but they're half a gig. So we could do vmctl console x. And you can see I'm just back at the same place I was before. So we migrated a machine to ourselves, but you could easily take that file and pipe it across SSH. You had a fast enough connection to another machine. So that's a quick demo of send receive. So that's a pretty cool new feature.
So when you send the VM, it stops it completely?
Yeah. Yeah. When you send it, during the time it is starting to send until the time it is completely received, essentially the VM is stopped. Yeah. So it is.
But when the receive's over, the VM's not running anymore.
On the original host,
right.
Yeah. It's not a clone. It's an actual pick it up and move it kind of idea.
Right.
And how about like a network service and these kind of things like that? How about when you have a network service, let's say like a NFS, mount points, these kind of things, like what happens?
Yeah, that's what I was mentioning earlier. I'm not a network person, but the idea behind send and receive in conjunction with switch and switchd was that it's just like moving a VM on another hypervisor product. So if you had a switch that was able, like a software-defined switch, that was able to move the connection, then as long as you still have access to the same infrastructure, then it would work okay, IP addresses and such. But yeah, it's just the VM itself is just connected to a tap on the host. So as long as that can be migrated with some kind of software-defined switch, that would work. I'm happy to kind of write down these questions and get back to you, but again, that's not my area of expertise.
Yeah, it's quite weak actually, like for NFS,
NFS might be tough just as acting as a user of NFS, even between my laptop and my NFS server at home, sometimes it's bad, so I can imagine what kind of situation that might create.
As long as the switch realizes that this MAC address is now over here, everything should be fine.
And in vm.conf, which is the configuration file for the VM, you can actually pick whatever MAC address you want. You can overwrite it.
To make sure that it stays the same after the migration.
Yeah. And I'm sure the folks with more networking expertise can tell me where I'm wrong there. All right.
I don't So I understand why there is a problem, let's say, with networking, but you could just give like additional parameter for the disk, right? Just to have exactly the same, because you mentioned that you could need to have exactly the same path to the disk, right?
Yeah, that's true. Today, what we do is we record the original location where the disk was defined when you started the VM.
Yeah.
So when I did the original VMCTL start AMD64, it got the disk information out of the config file. And there's nothing stopping us from just passing an alternate disk parameter. On the receive side, it just doesn't open. So whatever path you give it, that would work. We package up the original path in the expectation that if you're moving VMs between machines, you're probably going to have some kind of shared NFS location for the disks. But there's nothing stopping you from potentially implementing that. There's nothing specific.
Okay. Or did you think about also sending the disk with the VM?
Yeah, that's an interesting question. I think instead of going that direction, what we would probably do is we would probably switch our disk format, which is just raw and flat today, to something that actually offered snapshotting and snapshotting capability automatically. Because trying to send that disk, and this machine has like a 100 gig disk, it's going to take a long time. Especially looking forward to live migration, that would really become difficult. But QCOW2 has snapshot codes built in that you can build in, and if somebody wanted to help out, that's kind of a self-contained area of VMD that would be an ideal place for someone to get started.
I think almost all of my live migration depends on independent third place for the disk that's accessible.
Shared disk, yeah. It's really conceptually no different than other hypervisor products. All right.
Anyone else?
Oh, sorry.
At some point, and I know you're not a network guy, but do you know if Rake used the built-in OpenBSD DHCP server, or wrote a new one, or grabbed another one?
I don't know where the source of that code was. We can probably find out. He may even be watching. I don't think it was rewritten from scratch. It probably took pieces from places, but. So, 2018 goals, where do we want to go this year? Well, isn't every year the year of reduce the bug count? And I think that's true again, and it's always my lofty goal to decrease the bug count every year, but it just seems to grow and grow. I guess that's good, it means people are using it. We've got lots of new faces at the VMM table. We've got, like I said, Carlos and Pratik and some of the other folks from the list that have stepped up. I'd like to solicit more community involvement. I'm surprised as this last 24 months has progressed how many, hey, how do I do this with VMM emails I'm getting, which is good. It means people are using it in anger. Most important point is to continue Pratik's effort around the instruction decoder, because to be honest, I think we've gone as long as we can go. We've ridden the horse as long as it'll last before we'll need proper instruction decoding and emulation. To go any further with any of these topics down here like SMP or shadow paging support for older CPUs, more BSOS support for anything else that's out there, we're going to need this piece. So we're probably going to have to complete that. And part of the reason we don't work on FreeBSD is this first set of bullet items here. Our hardware emulation is absolutely minimal. We're emulating a machine from like 20 years ago. And like I said, 1997 called and they want their PC back because we don't have a local APIC emulation, we don't have ACPI, none of this stuff. And it's quite amazing that it actually works as well as it does, missing all these pieces. So we'll have to do that at some point, and I think this year will probably be that year. And then of course, did I mention fix bugs? All right, so one last thing I'll leave you with. We, of course, have OpenBSD hackathons all the time. Last summer in Toronto, a bunch of us were sitting around having beer. No, not this again. Seems like every time I talk about VMM at BHackathon, it ends up something having to do with beer. So we were sitting around having beer, and we were really talking about how to use VMM now that it was kind of stable enough in the kernel side to possibly help secure memory. And this is not really having to do with virtual machines and running Linux and stuff. It's really how do you use the technology you've built to help improve the security of the host. So this is part of a broader conversation about reducing attack surfaces. And for those of you that follow OpenBSD, you've seen Carl and some of the other things that have gone in to help improve this area. But what we thought was, well, we have nested paging, and that's what VMM uses. On some Intel CPUs, you can configure the page permissions to be execute only. And what this means is you can create a page of memory that can only be executed but can't be read. Now, how does that help you? Well, could we use this to protect pages from scanning? So is it possible to use this to help defeat some kinds of things like this, like scanning for gadgets, and generally just not allowing people to do things that they shouldn't be doing? There really is no reason to be reading this code unless you're a debugger. So is it possible that we could use the technology that's built into VMM to protect the host itself? So in order to do this, you actually have to be running the host itself as a VM. So here's an idea. Why don't we start VMM early, like early in AutoConf, where we do today. At the point where VMM attaches, because if you haven't seen what it attaches, it just looks like a device in the device tree. Once you do that, you turn the existing host into a VM. And then you look through the kernel and you take all the code pages and you convert them to execute only. So basically what this does is it hides all the kernel text. Now this is not a new idea. I mean, this is old. I mean, Bluepill did stuff like this a million years ago, and there's probably other people that did similar things. So I'm not claiming that this is some brand new idea. It's just we have this technology, so why not try to make use of it? Now, there's some problems with this approach. There are some legitimate needs to read memory. And the debugger is one, and there's also things that get generated in the compiler called data islands. These are things like switch case jump tables and stuff. And also, once you turn the host into a VM, then how do you run additional VMs? So there's some compatibility concerns. You can handle DDB fairly easily. What we did is we just turned that into a VM call instruction, and we exited what's called the host VM at that point. And then, but you need to make sure that that doesn't become a new gadget for somebody to escape themselves out of the execute only page. The switches and jump tables and data islands, they were a problem with GCC when we were still using GCC. And then we had somebody go in and fix that, so they become not a problem. And then when we switched to Clang and LLVM, it doesn't appear to be an issue anyway, so that kind of just went away. Compatibility with VMD requires at least some nesting support. So a shadow VMCS or some kind of emulation, exits for VMX instructions. And then because you're now running the host itself as a VM, it's not that easy to use VMD as the scheduler anymore. So now you need some kind of scheduler in the kernel. So this is not quite done yet, but fortunately I had that nesting tree from a number of years ago that I was able to pull some pieces out of. So this is in the works. So the early proof of concept of this, after we spent a couple of months working on Meltdown, I said I needed a break. So I went back to this, and it's about a 1600 line diff, protects kernel text, doesn't do any nesting. The idea is once you get this working, you take this and you build userland protection for it as well. So you make your userland applications execute only and not readable. This really helps cut down on the amount of ROP nonsense that's going on. To do this, we need some more work. We need actually something called copy on read because of the way that text is shared between libraries. So we're going to do the kernel first and userland later. So this is using the core VMM technology to do something that we originally had intended to do. And I didn't coin that term. I saw that somewhere before. I don't remember who called it that. If someone knows, let me know, but it seems appropriate. Basically, you're taking a host and putting a hypervisor underneath it. So, again, if the demo gods smile on us. This one, I'm going to show you in Box, which is a system simulator. And the reason I'm going to show you in Box is because it allows me to break in and show you what the protections look like. Of course, you wouldn't run it like this normally. So this is an OpenBSD VM running here. And this is with the underjack capability running. So I'm going to stop it during AutoConf. And just really quick, I'm going to move this out of the way. I'm just going to pick a page of text here. And you don't have to be a TMAP hacker or anything to know. This is just a 4-level regular page table. And it's just got whatever protections it's got. I'm going to continue. So this is before we've engaged that new mode of operation. seconds. All right, so if you look at where we are now, it's kind of hard to see right here. For those of you who've used OpenBSD VMM before, you're familiar with seeing VMX EPT. We now have this other capability. So at this point, when we attach VMM, we start this host as a VM mode. So from this moment on, this host is actually a VM, and it's a VM running under VMM contained in itself. So it's, if you were to look at this now, grab that page. So remember, we haven't started VMD or any VMs or anything. We're still checking file systems. That's how early we are. If I look at this page, it happens to just be in user memory. It doesn't really matter, userland. What you see is quite a bit more stuff. And again, without going into too much detail, what this is showing is that everything is being protected with nested paging. So you can apply whatever kind of page table permissions you want underneath this. And in the kernel text, we protect it with execute only. So that if something got into the kernel and tried to scan through code to see what was there, it would just fault immediately. And you'd crash the machine, which is what we want. So again, these pages here have the full permission assigned because we haven't done userland yet. But ideally, if these were code pages that I was looking at, which they are because I stopped in an instruction, this would just simply be E blank blank. So you'd be able to execute it but not read or write it. So this is something we're looking forward to. As time permits, we'll continue hacking on it. Again, I had this in a side tree for a number of months, and I decided that it was time to dust it off to clear my brain from Meltdown Inspector for a while. So that's kind of all I have, and that's the update. When I first started thinking about the presentation, when you reached out to me, I said, "Oh, there's probably not a lot to think about, not a lot to talk about," and then it's actually bigger than all the other presentations. So hopefully this has been interesting. Give you guys a feel for where we're headed and where we are, and I'll take any questions.
Two questions.
Sure.
So how would you compare, if possible, the underjack to the way Zen works on any of its platforms?
Different. Yeah, it's just taking an existing hypervisor, putting it underneath the VM, and then putting it underneath the host, and then turning it into a VM. Again, we're not the first ones to think about doing that. That's been around for many, many years. Yeah, I don't know. I mean, I know Zen is the Zen effort around, specifically around recently trying to fix some PV-related workloads to come up with some kind of encapsulation technology, but I'm not too much of an expert there. So, yeah. Second question.
Well, what if we had the RAM disk contain enough of the VM stuff to actually boot the kernel, the main kernel, in the VM the first time? Like have basically almost no host running underneath the VM.
Yeah, I mean, you could thin that out almost completely. Sure. The way that it works today is the host VM, if that's a term, and the actual host underneath that's running the VMM code, they actually are lined up perfectly in memory. But yeah, there's nothing stopping you from just creating something like a super micro little shim with a little bit of runtime to do the scheduling. That would work. That would be more like what Zen does. Yeah.
And you mentioned dusting off a nesting tree, so the same question.
So Michael Dexter's favorite topic, nested virtualization. Last year, it was kind of like I left it up, have an open question. What looks more interesting, having better guest support or having better nesting? Nesting lost last year. What I can say about nesting is it's become more important with this, and I've got it to the point where I've got all the exit handlers rebuilt because that tree was so old. Rebuilt for all the VMX instructions. Shadow VMCS is there, but I don't have nested paging yet. But that will become more important, and who knows, maybe BeehiveCon 2019 we'll be talking about that.
And you touched on Meltdown Inspector. Quite a few of our regular speakers are not here because they've been tied up pretty much all year with that wonderful adventure. Can you tell us just about what's been involved with that and what it means for VMM?
Not specifically much for VMM. There is one piece I still need to do for VMM. relating to the spectrum mitigation for on the VM exit, flush the branch target and stuff. That should be fairly mechanical and straightforward. Nothing specifically needed for the VMM side of things. There's, of course, was a lot of work that went on elsewhere in the main OpenBSD kernel, but for VMM, no. Not that I can think of, with the exception of the one thing I just mentioned. Cool.
Other questions?
Well, I'll be here all day and at the main conference, so if someone sees me in the hallway and has any other questions, feel free to walk up and ask.
Cool, thank
Thanks
you,
for
Mike.
having me again.
My pleasure.
That.